Snake bites, though often perceived as rare and exotic threats, remain a significant concern for millions of people worldwide, particularly in rural and tropical regions. Introduced in the heading, "The Threat of Snake Bites and Human Survival." This concept highlights the life or death situation faced by many when they encounter venomous snakes. Globally, it is estimated that snake bites affect 5.4 million people annually, resulting in up to 2.7 million envenomations and between 81,000 to 138,000 deaths. Beyond these statistics, countless victims suffer permanent disabilities and disfigurements. Thus, the threat of snake bites is not just about survival, but about enduring impacts on health and communities. Understanding this threat is crucial in appreciating the urgency and importance of developing and utilizing antivenom. Antivenom is a life-saving intervention that neutralizes the toxins present in snake venom, significantly reducing the mortality rate. The impact of effective antivenom can be observed in countries like Australia, where rapid access to treatment has dramatically decreased fatalities, showcasing the scientific and humanitarian success of these medical advances. Similarly, India, which reports the highest number of snakebite incidents globally, benefits greatly from locally produced antivenoms, although accessibility still remains a challenge in rural areas. Opinions from the medical and scientific community underscore the necessity of antivenom. Experts advocate for increased funding and research to improve the efficacy and availability of antivenoms, reflecting a shared understanding of their crucial role in snakebite management. However, challenges persist. The production of antivenom is complex and expensive, often resulting in limited accessibility for those in developing regions where they are needed the most. There's also the issue of specificity, as antivenoms are typically species-specific, requiring detailed knowledge of the type of snake involved in each incident. Controversies also exist in terms of production practices, as it traditionally involves the use of horse serum, raising ethical considerations. Furthermore, alternative viewpoints suggest that more emphasis should be placed on preventive measures, such as education about avoiding snake habitats and using protective clothing, to complement the use of antivenoms. This introduction primes the audience for a deeper dive into the science behind antivenom, setting the stage for exploring how medical innovations in this field have stemmed from understanding the unique threat posed by snake bites. The overarching narrative ties the urgent need for antivenom development and distribution to broader themes of healthcare accessibility, scientific research, and public health strategies. Understanding the process of how humans survive snake bites involves delving into the marvels of antivenom, an essential life-saving medical development. Antivenom, also known as antivenin, is a biological product used to treat venomous bites or stings. It is specifically designed to counteract the effects of toxins or venoms injected into the human body by creatures like snakes, which release venom to immobilize prey or for self-defense. The significance of antivenom is profound. It transforms potentially fatal encounters with venomous snakes into treatable medical emergencies, highlighting the crucial role of scientific advancement in modern medicine. Real-world applications of antivenom illustrate its importance. For instance, in regions like sub-Saharan Africa and South Asia, where incidents of snake bites are prevalent, the availability of antivenom directly impacts survival rates. In these areas, antivenom can be a deciding factor between life and death, showcasing its life-saving capability. Another example is in rural areas of Australia, known for its endemic venomous snakes. Rapid administration of specially formulated antivenoms helps neutralize the venom's effects, preventing significant tissue damage or systemic failures, underscoring its practical significance. Support for the indispensable role of antivenom comes from various medical professionals and health organizations. They emphasize the reduction in mortality rates and improved outcomes due to timely administration of antivenom, demonstrating its efficacy as a cornerstone in snakebite management. However, there are challenges associated with its use. The production of antivenom is costly and complex, often requiring venom extraction from the snakes themselves, immunization of host animals, and meticulous purification processes. This complexity can result in limited accessibility and affordability, especially in low-income regions burdened with high snakebite incidences. There are alternative viewpoints concerning the sustainability and ethical considerations in antivenom production, prompting discussions about the development of synthetic antivenoms or novel therapies. Despite these controversies, the interconnectedness of antivenom with existing medical systems is undeniable. It's crucial for the continuation and expansion of effective snakebite management. In summary, antivenom not only serves as a direct response to snakebites, but also influences public health strategies, preparedness programs, and global health policies. Its development and distribution are intrinsically linked to a broader understanding of snakebite impact and management, demonstrating its pivotal nature in enhancing human resilience against these venomous threats. Snake venom is a complex cocktail of proteins and enzymes, each with a distinct purpose, designed by nature to subdue and begin the digestion of prey. Depending on the species, snake venom can include neurotoxins, hemotoxins, cytotoxins, and other components that attack the human body's nervous system, blood, or cellular structures. For humans, even a small amount can lead to paralysis, internal bleeding, tissue damage, organ failure, or, in some cases, death. Understanding the composition and effects of snake venom is crucial to developing effective treatments, particularly antivenom, which can neutralize the venom's life-threatening impacts. Understanding venom composition is paramount because it underpins how antivenoms are formulated, making it vital for medical science and public health. For example, the neurotoxins in cobra venom target the nervous system, potentially leading to respiratory failure. On the other hand, the hemotoxins from a pit viper attack the blood, causing clotting disorders. These differences mean that antivenoms must be specifically tailored. A broad-spectrum approach can be ineffective or even dangerous. Real-world applications of this understanding are evident in the creation of region-specific antivenoms. In South and Southeast Asia, the big four snake species are responsible for the majority of venomous bites, prompting local healthcare systems to prioritize antivenoms that address these particular venoms. Similarly, in Africa, polyvalent antivenoms have been developed to treat bites from several prevalent snakes, reducing the mortality rate significantly. Experts acknowledge the benefits of these developments, with many healthcare professionals advocating for expanded research into venomous species globally to reduce the incidence of snakebite deaths and long-term disabilities. However, challenges remain, including the time-sensitive nature of antivenom administration and the cost of production, which makes access difficult in some regions. Additionally, there's controversy over the potential side effects of antivenom and debates on the improvement of production methods, including the potential role of synthetic biology. This understanding of snake venom directly influences how medical professionals approach treatment, highlighting the importance of rapid response and accurate identification of the snake species involved. Moreover, it prompts further research into alternative therapies that could complement traditional antivenoms, potentially leading to more cost-effective and widely available treatments. In essence, understanding snake venom and its effects creates the foundational knowledge necessary for tackling the broader topic of snakebite survival through medical intervention and scientific innovation. Antivenom is a life-saving medical treatment specifically designed to counteract the effects of venom injected by snakebites. It is created by immunizing animals, such as horses or sheep, with small, non-lethal doses of snake venom. Over time, these animals produce antibodies that neutralize the venom's toxic components. Scientists then collect and purify these antibodies to produce antivenom serum, which can be administered to humans suffering from envenomation. The significance of antivenom in the context of snakebite survival cannot be overstated. It remains the most effective treatment for neutralizing venom and mitigating damage to human tissues and vital organs, thus significantly reducing mortality rates and long-term complications from snake bites. Real-world applications of antivenom are widespread, particularly in regions with high snakebite incidence such as Sub-Saharan Africa, South Asia, and Latin America. For example, The Tab Plus ICP antivenom is used in Nigeria to combat bites from carpet vipers and other deadly snakes prevalent in the region. In India, which accounts for nearly half of all global snakebite deaths, polyvalent antivenoms are crucial for treating bites from the big four snake species: Indian cobra, common krait, Russell's viper, and saw-scaled viper. These examples highlight the critical role that antivenoms play in frontline medical care, saving thousands of lives each year. The importance of antivenoms in the medical community is strongly reaffirmed by experts who emphasize their irreplaceability in treating venomous bites. Medical professionals advocate for increased research funding and development to improve antivenom efficacy and accessibility, especially in impoverished communities where the cost can be prohibitive. However, antivenom production faces significant challenges. A major issue is the geographical mismatch between where antivenoms are produced and where they are most needed, leading to shortages in high-demand regions. Additionally, the production process is complex and expensive, which contributes to limited availability and high prices. There are also risks associated with antivenom treatment, such as allergic reactions or serum sickness in some patients, prompting ongoing research into safer and more cost-effective alternatives, such as monoclonal antibody therapies or synthetic antivenoms. Finally, understanding antivenom not only underscores the importance of medical responses to snakebites, but also highlights the need for preventative strategies, education to reduce snakebite incidents, and global cooperation to ensure equitable distribution of these critical medicines. The interdependence of these elements forms a comprehensive approach to combating the impact of snakebites on human health.